In this video 5.7, we're going to be looking at scatter plots and trend lines. By the end of the video and work time in class, you should be able to say, I can write equations of trend lines and lines of best fit. A scatter plot is a type of graph that relates two different sets of data by displaying them as ordered pairs. One type of scatter plot you may see is a positive correlation. This is when y tends to increase as x increases also. The two sets of data then have a positive correlation. So we know that this is our x-axis, here's our y-axis, and if you see that you have a bunch of ordered pairs, now they're scattered. This is a scatter plot. Once again, you look at that, the name of these scattered, these points are going to be scattered. There's no straight line. There's no perfect kind of image you're seeing. You're just going to have points scattered. But in a positive correlation, the data, when you graph these points, is going to be going upward from left to right. So once again, this is a positive correlation. As x increases, y also increases. Your points would look something like this. An example, if I was collecting data on, let's say, babies, and I was looking at babies' weight over time of their first year of life, as their age increases, their weight increases. So if I took data and plotted those points, I would see a positive correlation. Not all babies are going to be weighing the same amount at the same age. Not all babies grow at, and it's very uncommon for babies to grow at the same rate. So if you took data from various babies over the course of the year, your points are going to be scattered, but you would see a trend that it would be going up. As weight is going up, the age is going up, vice versa. Two things increasing, positive correlation. A negative correlation is when the y tends to decrease as the x increases. The two sets then is a negative correlation. So if this is my x and this is my y, you would see ordered pairs going down from left to right to give you this negative correlation. An example of this would be, let's say you purchase a car, and as the age of the car increases, the value decreases. One thing increasing as another is decreasing. No correlation is when the x and the y have nothing to do with each other. There's no relation at all. So if you graph the points, you wouldn't see a trend. You wouldn't see points going upward. You wouldn't see points going downward. They would just be all over the place. That would be no correlation or no trend. Here we have a table that shows the amount of time spent studying for a final exam by 8 different students. And it gives us how many hours and their grade on the test. So we have all these ordered pairs, specifically 8 ordered pairs. On the x, we're going to use hours. We're going to label our x-axis hours. And then we're going to label the y-axis our grades. And so we're going to plot these 8 points, but first I'm going to, let's say for hours, since for hours it looks like our highest hour is 7 here, and this one right here is 2 down here. So if 7's our highest, for hours we can go up at an interval of 1. For the grades, it looks like our highest is, 94. So, excuse me, so we're going to have to change the interval here. I'm going to go up by 10s. And so then from here I'm going to plot my points. $7.88, $3.79, $5.92, $1.71, 0.62, 6.94, 4.82, and 2 was 65. So here we can see when we plot these 8 ordered pairs that there is a trend. You can see that the points are scattered. It doesn't make a perfect line, but if I drew kind of a line estimating where my points are, we see it's going upward over time. As the amount of time increases that they're studying, their scores are going up. Not necessarily. You see the person that studied the most was 7, they got an 88, which wasn't the highest score. But the trend is showing us overall that the more you study, the higher your grade. So this right here would be a positive correlation, or a positive relationship is another word you can use for correlation. Relationship or correlation. The trend line was that line that I just drew in with my green marker there. It's a line on a scatter plot drawn near the points that shows the correlation. It kind of takes all of your points and estimates a line going through all those points. That line is a line of best fit. It's a trend line that shows the relationship between two sets of data most accurately. Now, if we had a graphing calculator, we could find that line of best fit in the assignment. If it tells you ever to use a graphing calculator, just ignore that. You don't need a graphing calculator. What we'll just do is estimate where that line is and be reasonable in what we use for our slope and our y-intercept. So we'll do an example of that here with this data, which is showing us the population of deer over a 12-year study. So we're looking at or specifically, I guess we're looking at 8 years, it looks like, the data for the population of deer. So we have years and we have population. So on the bottom of the graph, we're going to write years. On the vertical, we'll write population. So we're looking at the population of the deer here. For year, we can just go at an interval of 1, but for the population, it looks like we're going to want to go up by like 250. So I'm going to go, so I've got 0, 500, I'm going to skip here, 1,000, and then just I'm going up by 500s then at this point. So 1,500, 2,000, and then 2,500. So we're going to plot these points here. Year 1, the population would have been 1,260, so right about in here. Year 2, it was 1,375. Year 3, it was 1,310. Year 4, 1,490. Year 5, looks like we're at 1,625. And then we're at 1,680. 1,740. So right about in there, closer there. It's not perfect, but we're going to get an idea here. After 1,740, it then goes down a little bit. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, we've got our 8 years. And when we draw that line of best fit in, we kind of estimate, and there we go again, with this smartboard not giving me a line. That gives us a good idea here. We're just kind of estimating where that line would be in between all of those points that are scattered. Looks like my 1 year just erased when I did that. That would have been year 6 was at 1680. So then, okay. So then at this point, we see it as a positive correlation. It's a positive trend. But now, to write this equation in the form, let's say, of y equals mx plus b, we're just going to kind of estimate here what our slope is and what the b is. Now, if I come over here and look at how things are changing, it looks like we're going up 115, and then from here to here, we're going down 65, and then we go up 180, and then we go up, or sorry, this is not 180, or is it? Yeah, it is 180. And then it looks like 135. Here, this looks messy. So 180, 135, and then 55, and then let's see, then it would be 60, and then from here to here it went down. So it did go down, it looks like 2 different times, from year 2 to 3, and then from year 7 to 8. But we do see overall it's going up over time. And so if we kind of average that slope, we could say somewhere around a slope of like 75 is the rate of change. Now, we can also look at how much, if we look at this green line, how much is it going up, you know, for 1 year. So we want to look at our steps here. So over, if I use a different color here, over 1 up, this, over 1 up, over 1 up, over 1 up. And how much is it going up in this line? It would be, you know, if you take our interval of 250, you know, if it's going up about this much, it's somewhere around 75. I would be flexible though with how much in terms of your increasing there, but it would be somewhere around that slope. Now, when we look at the y-intercept, where is it crossing? Well, it looks like it's pretty close to 1,250 or like 1,200, somewhere in there. And so once again, this is just an estimate of what that equation would be. And so then in the 12th year, if we replace x with 12 and we do y equals 75 times 12 plus 1,200, we're going to get an estimate, once again it's an estimate, of 2,100 deer if we're studying population of deer. Causation is when a change in one quantity causes a change in the second quantity. So when there is definitely a relationship, one thing affects another, that's called causation. So we're going to look at a couple situations here where we're going to look to see if there is that causation, which is a correlation. So if so, does this correlation reflect a causal relationship? The height of a student and the grade earned on a quiz. There would be no correlation because there's no causation here. That your grade isn't affected by how tall you are, so no correlation here. In this next one, the price of bananas at a grocery store and the number of pounds of bananas bought. This one would be a negative correlation. And the reason why this one is a negative correlation is, first of all, there's this relationship with how many bananas are going to be sold is definitely depending on the cost. So the cost is the price decreases, then you will sell more. So as cost goes down, you will sell more. so sales go up. So costs going down, sales going up, that's a negative relationship or a negative correlation. One thing is increasing and the other is decreasing. Or vice versa, as the price increases, the amount of sales goes down. Price increase, sales decrease, one up, one down. That's a negative correlation. The price does affect the sales, so that is definitely a causal relationship. That causation is occurring there. A change in one is causing a change in another. Once again, in the work, whenever it tells you to use a graphing calculator or any kind of correlation coefficient, ignore those. That's using those calculators. We're going to estimate like we did on that deer problem. Can you say I can write equations of trend lines and lines of best fit? Be prepared with any questions for the work time in class.